Welcome to Learning Elixir, where we try to teach my friend Elixir. He already knows a bunch of languages, and now he's supposed to learn Elixir. And we do this using the Elixir School curriculum, which is open and free and seems pretty good from what we've done so far. We're moving along at a snail's pace because we're doing a course every week, and these are fairly bite-sized initially, at least. But it's nice doing something slowly sometimes. So the topic today is pattern matching, which was one of these things I hadn't heard of much before moving into Elixir, and I definitely hadn't grokked it. Had no idea what it was good for, in spite of you actually having attempted to explain it with Haskell to me once.
That must have gone really well, since you didn't grok it.
Yeah. So I think pattern matching suffers when you try to explain it with synthetic examples.
Yep.
And I'm curious to see how this curriculum actually does it, and whether I'm not sure I will be able to tell if you will learn pattern matching from this, because it's going to be self-explanatory to someone who already knows it. But
exactly, just map it onto the patterns already in my hand.
Yeah. But pattern matching is incredibly powerful, and I think it's sneaking into more and more sort of object-oriented languages, and I have a really hard time feeling like it makes all that much sense there. But I guess if you have an object that you know the structure of, being able to sort of destructure it and access parts of it in different ways probably makes sense.
Yeah.
So yeah, destructuring is definitely a thing in JavaScript already, and it's very close to pattern matching.
And it's really powerful.
Yeah.
Okay. So, in Elixir, we can pattern match on simple values, data structures, and even functions. And the equals operator is a match operator.
Yeah, so this is the big mind-blowing thing about pattern matching, especially at least in Elixir, but I think that this is typically how it's done in many FP languages, at least if they allow a sort of assignment. So you don't really set something to... You don't really assign. It's more that you describe how it matches. So
yeah,
it has mostly the same results. So we say x equals 1. Okay, then x is 1.
And then we can use 1 and x interchangeably.
Yeah, but if we look at the next one, then we say 1 equals x, which is fine. But then we say 2 equals x, and then it's no match, a right-hand side value 1. Because this x here is still 1. So
exactly. And 2 does not equal 1.
And this is not very useful for numbers. But we can see here that if a match fails, it will throw a match error. And that's something that you tend to rely on here and there in Elixir and OTP.
Cool.
Just part of the sort of let it crash philosophy, where you don't try to handle every error if there's no particular way to handle it. Sometimes it would be probably nicer to raise something specific if there's a sort of expected match error.
Yeah.
All right. Then we go into some collections, and this is where it gets a bit interesting. So we bind a list to the word list.
Yep.
And then we can match that to a literal list on line 3 there.
Yep.
And that's fine.
because they are the same, really.
Yeah, and
By
because
now.
we're not dealing with sort of comparison by some memory reference, but rather this is, do these contain the same? Is the question being asked? Are
Yeah.
they the same? Um,
Structural equality.
yeah.
Good stuff.
And then we have this where we
Yeah.
try to match it to an empty list, and it does not match the list 1, 2, 3. But
So this is
here's where we come to some special syntax. So this is the syntax for head and tail operations. So we're saying the first item in the list is going to be a 1.
Yep.
And the rest of the list is after this pipe. And then that one we can just bind to this variable so it can match whatever. And then we get this. So if we inspect tail here, it will return 2 and 3.
Yep.
So we say, assuming that the list starts with 1, we have 2 and 3 in this variable.
Nice.
In this binding. And if we try to do a similar binding down here, note here it's using the underscore, which is it's mostly treated as a special thing by syntax checkers, linters, and stuff, and the compiler, to say that this is an unused variable if it starts with an underscore. But note, this does not match because it does not start with a 2.
That's true. Yeah, I'm gonna try something stupid because I need to do that now and then. So can we get? There's a 1 there, and let's call that one Y because that's not used, and then do that and see
compiler error. So what you're trying to do is get the first item of the
I want the second
of the tail.
element.
Yeah, you want the second element. So then you're missing this.
Got it.
So it's a list in a list.
Yeah. Because the Haskell syntax for it is flat.
Okay.
So that fooled me.
Yeah. So yeah, we can do this as deeply as we feel like, essentially.
Yeah.
It's also fine to do that.
Yeah. So we can pick out the 2 first elements.
Yeah. Then we can return them as a tuple.
Oh yeah.
Yeah. Just restore this example.
Yep.
But yeah, and then we have tuples.
Yes.
Or tuples. I don't know how people prefer pronouncing it. It seems to be.
I think you should pronounce it like
to place.
Yeah, or first you pronounce it tuple, and then tuple, and then tuple, and so on. So you need a counter in your head.
That seems inconvenient, but okay.
Yeah, but it's the correct way.
Cell puts. Oh, yeah. So we have our literal tuple here.
Yep.
We pattern match it to OK and value.
Yep.
So this means that if this was a function call and it returned something other than OK and a value, it would be a match error.
Yes.
So if we only care to make sure that we don't proceed with the code, if we get a non-OK value, then this type of match is a very quick way to ensuring that it throws a match error there or races. I can never keep straight the difference between throwing and racing in this language, honestly.
So this is a bit like Golang, but the other way around. Because in Golang you have to handle all these. Is it a nil? Is it not a nil? While in Elixir and Erlang, for that matter, you can just go, it failed.
Yeah. It's fairly dynamic in that way. And here
Yeah.
we have, so this is a failing match for a tuple.
Cool.
So this is a single item tuple with error in it.
Yeah. If everything goes bad and you just don't wanna.
Usually you get error tuples without an actual reason in them.
Yeah.
but yeah, so this is what you'd see if you fail the match.
Cool.
Now the pin operator. Or does all of this stuff seem familiar to how pattern matching works in the languages you're used to?
Yep. I want to do something more silly.
Okay.
Because
Silly away.
silliness is important for my learning experience. To the great chagrin of teachers all over the place.
Yeah.
This let's see, like that. Okay, let's see what happens.
Variable value in code block
That's
has no
fun.
effect as it is never returned.
Okay, but that's good. We can. It's one of those. Python has destructuring and pattern matching, but not too. It's not as powerful as in Elixir. But one of the use cases.
I'm not sure
there,
you're doing what you think you're doing there.
Let's see. So Z is 3 here.
Yeah.
And then W is high there. And
Yeah.
then we have Z there, W there, and I want to switch the values.
Yeah.
But it doesn't seem to do that. So
No.
that's kind of fun.
So you know what you're doing?
Nah.
You're binding Z on line 4.
Yep.
Then you're binding. Then you're creating a tuple with Z as the first key on line 6, and then you're matching that against a tuple with 2 bindings. So you're just rebinding to new identifiers.
Yep. And
so
that's what I want to do.
That's the next
Let's see if I can do this.
chapter. Yeah. Okay.
Oh, okay.
So.
Yep. No, it doesn't work. Never mind.
So what we would do if we want to use variables or rather bindings in a match, we need to use the pin operator. So we set up we set up X here.
Yep.
Then we want to check if our value 2 here is matches the value of X.
Yep.
Not bind it to X. It does not. But we use the pin operator. So this thing.
Yep.
And similarly here, then we can go. So what's happening here? It's like a tuple 2, 1, and then it's matching X, so that's 2.
And then rebinding X.
Actually, no, this is confusing.
Yep.
So it's still using the previous value of X there.
But
so this no. Oh yeah. So it's not picking up the inline value of X or in match value of X here, because the previous value of X up here was 1.
Yeah.
And it's matching against that. And when the match is complete, X will be 2 because of this.
Oh.
Yeah, so that's a weird and nuanced example if I've ever seen one.
Yeah. It's one of those you can have it as an interview question and then fail everyone. And it wouldn't be very good, but cool.
Yeah. And Elixir 1.2, which is ancient, introduced support for pins in map keys and function clauses. So, map keys. If we want a key to be hello, we can use the pin operator here.
Yep.
and we can see a match error here because we're trying to match it to the atom hello rather than the string hello.
Yep.
And then there is pinning function clauses. So this actually uses a syntax that I've seen like 3 times and haven't personally used much, but I'm sort of deciding if I should start using it because I rather like it, but it also seems like it might be confusing to people. So this is an anonymous function with multiple function heads.
Good stuff.
Yeah. So we set up greeting to be hello. We create bind a function, an anonymous function called to the identifier greet, and we say okay. So these are the arguments it takes.
Yep.
And here we're matching with the pin operator that we expect. We will only hit this part of the function if greeting is hello. Otherwise, greeting will go down to this one, which binds to anything and matches to anything. And so if we evaluate that one, so the first call here was hello, Sean, and it will give us hi, Sean, because it's shortening hello into hi.
Yeah.
So these are multiple function heads, and in Elixir you can write this as like the typical thing would be if you had a greet function and it had greeting name.
Yep.
So a full-bodied function would be this, and then you could. So, wow, I did not intend to open my inspector, but that's fine. Don't mind me. Keyboards are hard. So typically you wouldn't have function like you wouldn't have much to pin in a function like this because you don't have a bunch of bindings lying around in your modules.
Yeah.
But more typically you would use a literal based off a module attribute. And I'm sure we'll get to those eventually, but this would be but those are constants, compile time constants. But yes, essentially anywhere you're doing a match, you can use these pins.
Cool.
Which is neat.
Could we replace this part? Let's see. Gonna
just
try something.
Put the literal hello there.
Yeah.
Yeah, works fine.
Yep, no problem. I think that's less risky, but there's probably a nice.
Yeah, and maybe you very often need to refactor this word.
Yeah, of course.
Yeah, no, but so pattern matching in Elixir. There's nothing particularly weird about it, but I think that's one of, like in FP overall, one of the things that takes a bit of time to get used to because it is very different from how you typically do things. Yep. For example, if you have a map like this, and in a function somewhere you need to get the value of that, and you can do a.foo to access it. You can do a foo. So a.foo will throw if the key doesn't exist. A.foo will nil if the key does not exist.
Yep.
But you can also do foo my value equals a.
Yep.
Which makes it very nice, clear, and explicit, and you get it nice and bound, especially if you need to get a bunch of these things.
Yeah.
So
that's very nice.
And if you're doing that in a function, in many cases, you actually expect these keys to exist for the function to make any sense.
Yep.
And then you can actually just write your function like, so this would be my hello function. I can actually just go foo, like x and baz y. And if I want to if I actually want to have the map in its entirety, I can still have it bound to A.
Huh.
If I need to,
Okay.
for example.
That's good.
So maybe I need to now. I would need to write a module to actually run this code, I think. But if we want to output X and do some stuff with that, and then return A, so it's still pipeable, for example.
Yep.
So that's one way of doing that, and ensuring that the keys exist.
Cool.
Because otherwise this function will not run because it will not be matching.
Yeah. Can you change the value of foo? Like double it or something and then return A and have the change propagate?
So if I want to update the map of A, that means I'm making a new map because they're immutable, right?
Of course.
So there's a quick syntax for updating an existing key.
Yep.
So that's the wrong key. This is the quick syntax for updating a map.
Cool.
While you could also do map.put.
Which also evaluates to a map, right?
Yeah.
Yep.
So that would be typically how you update a particular section of a map. And it's like, I'm not sure how much of a complete new copy that actually makes. There's some optimization under the hood usually.
Yeah, but semantically, it's a completely new copy.
All right, so that's pattern matching, I think, for now.
Very nice.
Yeah. Today we learned.
Totally.
All right. Thanks for watching, and see you soon.